This is our second video where we look at calorimetry and how to answer this sort of question here that comes from the 2018 NCEA Level 3 exam on thermochemistry and particles. And it states that we've got 10.6 grams of ammonium chloride being dissolved in 65.0 mils of water, and that there is a decrease in temperature of 9.4 degrees. It's given us that total mass to work with, which is quite nice. We've got a specific heat capacity given to us, and we've got a molar mass given to us, and we're asked to find the enthalpy change of this reaction. Now, we see from it having a decrease in temperature that we know our final answer is going to be a positive number because it's endothermic. In our previous video, we worked out the amount of energy by using the equation Q equals mc delta T. So the mass of the stuff that changed temperature, 75.6, times the specific heat capacity, given in the question 4.18, times the temperature change, which was 9.4 degrees Celsius. And we don't worry about positive and negative in this case. So from that, we get a value of 2,970 joules, which we've now turned into kilojoules to work with here in this part. And that is because enthalpy change is given in kilojoules per mole. Do make sure you have a calculator for these sorts of questions, because you are going to struggle to do this sort of maths as mental arithmetic. So the next step is actually to work out the amount of the stuff that we actually have, so the amount that's involved in the chemical reaction. Now this does seem tricky because you've got ammonium chloride and you've got water, but the nice thing is the equation for this, I'm going to quickly jot down for you now. The equation for this reaction is just that we've got ammonium chloride solid going to ammonium ions, which are aqueous, and chloride ions, which are also aqueous. If we have a look at that, there's no water actually in here at all. The water is implied by the aqueous part, but there's no water molecules actually shown in an equation for this. So all I have to care about is the mass of the stuff that caused this change, and the stuff that caused that change was the ammonium chloride turning into ions. So I can actually work out the amount of that quite easily using this equation here, where the amount is the mass divided by the molar mass. And of course the molar mass is the sum of the atomic masses of everything in that formula. But again, it was given to us in our question as 53.5 grams per mole. So it was actually given to us. So it's sort of given us the answer in this one. We just have to know how to use it. So we plug those numbers in and we get that the amount of the stuff that caused the temperature change, the ammonium chloride, is 10.6 grams divided by 53.5 grams per mole, and we get 0.198 moles when we round that off to 3 significant figures. It had many more significant decimal places than this, but I am going to persist with my 3 significant figures because all of the data given to us in the question was 3 significant figures. Now I've got this, I can take my answer from the previous video and apply it to this one. Enthalpy change is the energy change divided by the amount. And in step 2 we worked out the amount. In step 1 on the previous video we found the energy change. So the energy change we found to be 2.97 kilojoules. We have just found out that the amount is 0.198, and we do a division there. And I used the exact values, even though I rounded off in my working, and got 14.99, and again many more decimal places, kilojoules per mole. You can see how it's kilojoules per mole, the units there, kilojoules, the units there, mole. So if you left this as joules accidentally, then your final answer would be in joules per mole. Then my last thing is to round this off to 3 significant figures, and I get 15.0. And then I have to do, is it a positive or negative value? If I go back to the original question, the temperature decreased. It got cold. And the way I tend to remember this is cold has 4 letters, endo has 4 letters, hot, so if I get hotter, hot has 3, exo has 3. So if you want to look at the contrast of that, for exothermic, there we go. So there's a nice easy way to remember. So if it was exothermic, of course, it would be a negative value in here. And now we've actually solved quite a challenging question that's got a lot of information and data in it and going, where do I start? So a reminder, step 1, you find the energy using Q equals MC delta T. Step 2, you're going to work out the amount of the stuff that actually caused that temperature change. And step 3, you put those two answers together, making sure it's in kilojoules per mole, making sure it's 3 significant figures, and checking that if it got hotter, it's a negative enthalpy change. If it got colder, then it's a positive enthalpy change.